In 2023, a geothermal HVAC system was retrofitted at the prestigious Beresford on Central Park West in New York City. The residents of the Beresford chose this hybrid geothermal and air source heat pump to service their lobbies, offices, and common areas. The installation is projected to reduce peak cooling demand by 18% and greenhouse gas emissions by more than 40%. However, the installation in this almost 100-year-old building came with significant challenges. Developed and implemented by Brightcore Energy, the plan required navigating a 12,000-pound drilling rig through narrow passageways and tight corners to reach an old coal storage room 30 feet below the basement. Once there, a section of the wall was dismantled. The challenge? Heavy equipment could not reach the drilling location in the sub-cellar. To solve this, a gantry crane was built on site, using structural steel I-beams and a pulley system to lower the drill body. Once positioned into place in the subcellar, a high-pressure pump was placed inside a sidewalk shed. That pump would run Brightcore's exclusive Vasara water hammer that is used to drill into the bedrock without pressurizing the ground beneath the building or creating the dust and debris associated with conventional geothermal drilling. A total of 13 boreholes were drilled to create 9 geothermal circuits, each up to 500 feet deep. And the project utilized inclined boreholes to capture a greater thermal mass. Outside the Beresford on 82nd Street, 2 cubic yard collection tanks were placed in a sidewalk construction shed. Connected by hydraulic lines through a vent in the building, they collected wastewater and sediments from the drilling operation. The total amount of wastewater was estimated at 60 gallons per minute, resulting in 20,000 gallons per bore. A vacuum truck collected the liquid 2 to 3 times per week. Each hole was then flushed, looped, and grouted. Next, all lateral holes were connected to the manifold, providing water flow through the supply and return pipe. Geothermal systems leverage the consistent temperatures beneath the Earth's surface. Pipes are installed deep underground. In the colder months, the system extracts heat from the ground through these pipes and transfers it into the building. In the summer, the process reverses, pulling heat from the building and dissipating it back into the earth. The Beresford's geothermal system utilizes ground heat exchange, or GHX, to optimize seasonal energy consumption. The exchange uses the earth as a thermal battery, storing heat during summer months and extracting it in the winter. Throughout the retrofit, Brightcore had to manage noise and vibration. Sound levels were monitored regularly with a handheld meter. Because of the proximity to the subway system, the MTA required a monitoring system on the east and west sides of the building. Weekly reports showed no significant vibration from drilling. The Beresford is believed to be the first New York City landmark to utilize 21st-century geothermal technology, blending its Art Deco architecture with climate mitigation and sustainability.